Hi, I am Preeti. In this video, I am going to explain exercise 9.2 from chapter 9, which is areas of parallelograms and triangles. Before start the question, just remember few points. Hope you remember theorem 9.1, which I already explained in my last video. So what was theorem 9.1? Parallelograms between the same base, means if we have same base, this, let's say this is A and B, so one parallelogram is ABCD, okay, and another one more parallelogram, let's imagine this E and F, okay. So there are two parallelogram here, one is ABCD and another one is ABFE. So parallelograms between the same base and same parallels are equal in area. That means area of one parallelogram ABCD equals to area of another parallelogram, which is ABFE. Okay, this is theorem 9.1. So that you have to remember. Another thing, on the same base and between the same parallel, if there is a triangle, one triangle and one parallelogram, so parallelogram is this, okay. So this is A, B, C, D is a parallelogram and PAB is the triangle on the same base AB and between the same parallel DC and AB. So area of triangle PAB equals to half into area of parallelogram ABCD. Means in both condition you have to remember same base and between the same parallel. Okay, so same base is in this condition, same base is AB and same parallel CD and AB. Here also same base AB and same parallels DC and AB, or you can say DF and AB. Okay, the other thing, area of this parallelogram ABCD is equals to what? Base into perpendicular, or base into height you can say, or perpendicular is better, or height also you can write down. So area of parallelogram is base into height. So if this is the base, so height on this base you have to draw one perpendicular line. So this is the height. So area of this ABCD equals to base, means AB, into what? Height is, let's say this is D into DE. So area of parallelogram ABCD equals to AB into DE. Okay, just 3 points you have to remember. Okay, now let's solve one by one this exercise 9.2. So what is question number 1? One picture is given here. Let me draw quickly that picture. This is A, this is B, C, D. This is one perpendicular AE and another perpendicular CF. Okay, so in figure 9.15, this ABCD is a parallelogram. AD is parallel to DC. Here, see, you can see, and CF is parallel to AD. You can see here also. If AB equals to 16 centimeter, AE equals to 8 centimeter, and CF equals to 10 centimeter. So we have to find out AD. AD equals to what? Okay, now see. We will just write ABCD is a parallelogram, correct? I am writing is a parallelogram. So what? Parallelogram means opposite sides are equals and parallel, correct? So AB equals to DC, right? Opposite sides AB equals to DC. Now area of parallelogram equals to base into height. So area of ABCD equals to what? Base DC into height. Height is AE. Okay, now again area of parallelogram, if we will use base as AD. So AD, if AD is the base, so what is the height for this base? This CF. Correct? So area of ABCD equals to DC into AE, and area of same parallelogram is also equals to AD into CF. That means we can say DC into AE equals to AD into CF. Right? Now put all the value DC. What is DC? DC equals to AB, which is equals to 16. So instead of DC, we will write 16 into AE. AE is 8. AD that we have to find out into CF. CF is 8. CF is 10. Okay. Now AD equals to what? 16 into 8 by 10. Means 128 by 10. That means 2.8 centimeter. So what is the value of AD? AD equals to 12.8 centimeter. Correct? Now second. What is second? If E, F, G and H are respectively the midpoint of the sides of a parallelogram. Means we have one parallelogram A, B, C, D, and E, F, G, H are the midpoint of this is the midpoint of AB, F is the midpoint of BC, and so on for G and H also. Show that area of EFGH equals to, means EFGH means area of this quadrilateral equals to half into area of ABCD. Okay, that we have to prove. Okay, now see what is this? This is the midpoint of side AB and DC. Means E is the midpoint of AB and G is the midpoint of CD. If we will match or join E and G, okay, so it's a property of a parallelogram. If we join the midpoint, means this midpoint and this midpoint, so G and F will be parallel to BC. So GE will be parallel to BC. Why? Because G is the midpoint of DC and E is the midpoint of AB, and ABCD is a parallelogram. Means DC is parallel to AB and BC is parallel to DA. Okay, so GE will be parallel to BC, and also BC is parallel to what? DA. Correct? Because this is a parallelogram, and in that parallelogram opposite sides are equals and parallel. That means BC is parallel to DA. Correct? So BC, DA, and here I joined midpoint, so GE will also be parallel to BC and DA. Okay, now you can see this triangle. See first triangle, let me write E, H and G. Means this triangle and this parallelogram, area of GDAE means this half part of this parallelogram and this triangle. So we can see there is one base which is GE and same parallel, DA parallel to GE. See, DA parallel to GE. So if a triangle and a parallelogram is drawn on the same base and between the same parallel, so area of triangle equals to half into area of parallelogram. So you have to write down, okay, there is one base, common base, which is GE, and between the same parallels AD and GE. So area of triangle GHE equals to half of this parallelogram. Okay, same logic for this side also. Area of triangle is FEG equals to half into area of parallelogram. What is parallelogram? GCBE. Okay, I am just writing here for base. Common base is GE and common parallels are GE and CB. So you can write it down. Here also common base is GE and parallels are DA and GE. Okay, now this is equation 1, this is equation 2. So add 1 and 2. Okay, now this area of EHG plus area of FEG equals to half into area of this GDAE plus half into area of GCBE. Correct? This plus this equals to this plus this. Half is common in both, so you can write bracket here. So half this plus half this means half common, or here I just wrote half, so let me remove this half common. So half into area of this plus area of this. Okay, now see EHG means this triangle plus area of FEG means this. Correct? So this and plus this. What is the result? This quadrilateral. So area of what? EFGH. Correct? This plus this equals to EFGH. Now half is common. Now see here. GDAE means this half part of this parallelogram and area of GCBE rest half part of this parallelogram means we can write here area of ABCD means parallelogram. The same thing we have to prove, right? See here. So this is done now. Hope it's clear for you. Okay. Now question number 3. P and Q are any 2 points lying on the side CD, DC and AD respectively of a parallelogram ABCD. Means we have one parallelogram ABCD and P on line DC. P is somewhere, any point P here, and on AD there is some Q here. Okay, and ABCD is a parallelogram. Then we have to show that area of APB equals to, so APB, this equals to area of BQC. So B, Q and C. This we have to prove. Okay, now see here, same base, same parallel. Since this is ABCD is a parallelogram, means AB is parallel to DC. Correct? Now same base, AB is the base. I am just writing it, same base, and parallels AB and DC. Correct? So same base and same parallel. One triangle APB. So area of APB equals to what? Half into parallelogram, half into area of what is the parallelogram? ABCD. Correct? Same base and between the same parallels, area of triangle is equals to half of the area of parallelogram, correct? So this is the condition. Now if we will imagine this base BC, so for base BC and parallel what BC and AD, correct? So same base and between the same parallels AD and BC. Since ABCD is a parallelogram, so AD is parallel to BC, correct? So same base and between the same parallels, area of triangle BQC equals to half into area of parallelogram. So in this case also parallelogram is same, which is ABCD, correct? So this is 1, this is 2. So from equation 1 and 2, what? Here also half into ABCD, here also half into ABCD. That means LHS will be equal. That means area of APB equals to what? Area of BQC. The same thing we have to prove, right? See, area of APB equals to BQC, correct? So this is proved now. Easy, right? You have to just follow 2 rules, so it will be easy for you to solve any question, correct? Now the fourth one. What is the fourth? In figure 9.16 there is one picture. Let me draw that picture quickly. A, B, C, D. P is a point on the in the interior. Somewhere P is here of a parallelogram. This is a parallelogram ABCD. Show that. Let me draw match from P every point. Okay. Show that. First one. Area of APB plus area of PCD means APB. This one plus PCD means this one equals to half into area of ABCD. Okay, means half in full parallelogram. ABCD is what? This parallelogram. Okay, now see here. For that you have to do one construction. What? From point P, just draw one parallel line as DC. Means let's say this is E and F. So draw EF parallel to DC. And DC is parallel to what? AB. Because ABCD is a parallelogram. So from point P I am just drawing one parallel line EF on line DC or AB, correct? Now see here, same base DC, same parallel line EF and DC. So area of triangle equals to half into area of parallelogram, correct? So base DC and parallels are DC and EF, correct? So that means area of triangle PDC equals to half into area of parallelogram means EFCD, correct? Now same condition for here, this side. Base, common base is AB and parallels are what? AB and EF. Okay, now this is the common base and these are the parallels AB and EF. So the triangle PAB equals to half into this parallelogram, correct? So half in area of what? PAB equals to half into parallelogram is ABFE. Okay, now this is equation 1, this is equation 2. So again 1 plus 2. Okay, now area of what? PDC, this plus area of PAB equals to what? Half into area of EFCD plus half into area of what? ABFE. Okay, now what is area of PDC? Area of PDC as it is we will write. So area of PDC plus area of PAB equals to half common and this EFCD. Area of EFCD means half this parallelogram and area of ABFE. ABFE means another half part of this parallelogram. That means full parallelogram means area of ABCD. If we will take half common, so half this will go out. Correct? So area of this half part of parallelogram and half part of parallelogram is again full parallelogram. Means area of PDC plus area of PAB equals to half of area of parallelogram. Correct? The same thing, see, the same thing we have to prove. Correct? So this is done now. Okay? You can also take this as equation 1 because in the second part of this question I will use this equation. Okay? Now what is the second part of this? What we have to prove? Area of APD plus area of PBC equals to area of APB plus area of PCT. Okay, let me draw that picture again here, so no need to see back again and again. This is ABCD, somewhere P. Okay, now area of APD, so APD this part and area of PBC this part. So here also I will do one construction. From point P I will draw one parallel line as AD. EF, let me write down EF. From point P I am drawing one parallel line EF from AD. Okay, so construction EF is parallel to AB. Okay, and this EF will go and will cross the point P. Okay, now again same logic. AD, same common base, parallels AD and EF. So I am not writing again and again. I am just writing area of this triangle equals to half into area of this quadrilateral, because same base AD and same parallels AD and EF. Okay, so area of APD equals to half into area of AEFD. Okay, now same this side also, same base BC and same parallels EF and DC. Okay, that means area of triangle PBC equals to half into area of that quadrilateral or parallelogram EBCF. Correct? Now add 1 and 2 as usual. So 1 plus 2. So area of APD plus area of PBC equals to half into, I will just write it in short, area of AEFD. This part means half part of this parallelogram, and EBCF, another half part of this parallelogram. Means if we will add these two area and half common, so area of ABCD. Correct? Now see, what is half into area of ABCD? in that I already solved this. Half into ABCD equals to, instead of half into area of ABCD, can we write this? Yes. So from equation A, what? Area of ABD, this, plus area of PBC equals to, what is half into area of ABCD equals to? Same question number 1. You can write down area of APB plus area of PCD. Correct? The same thing we have to prove, right? So this is proved now. Okay.